Hi, this is the homework review for Stretching and Shrinking, homework 1.3, corresponding sides and angles. ACE problems 6, 7, and 19 on pages 14 and 16. The first problem was suppose you reduce the design below with a copy machine. So you're taking the image and you're making it smaller. Which of the following can be the image? The thing that you're looking for here is that you maintain the aspect ratio. That is, your height and your width change at the same rate. So this is not the case with A. You can tell A is wider than it is taller. B is taller than it is wider. D is wider than it is taller. Really, C is the only version that's a smaller version of the original. It leaves the same height to width ratio, so it has to be C. 7. Suppose you copy a drawing of a polygon with a given size factor. How will the side lengths, angle measures, and perimeter of the image compare to those of the original? This is one where you could draw any polygon you want. I threw some examples out here to see what they might look like. You could have a rectangle, you could have a triangle, you could have any kind of shape that has more than three sides or more, any kind of polygon. What you're really looking for here is that you're understanding what the scale factor is, what the copy size factor is. So for the first example, it really doesn't matter what your shape is. If it's 200% bigger, then it's going to be 2 times bigger. So your new side lengths will be 2 times as long. If I were to look at my rectangle, I'd go from a rectangle that's 1 by 2 to a rectangle that's 2 by 4. I would double my side lengths. My angle lengths would have no change. This again is pretty critical because if you maintain the same shape, then your angles can't change. And your perimeter is 2 times as long. Again, if it's 2 times as long, I'm going from a rectangle that's 1 by 2 to a rectangle that's 2 by 4. So I'm going from a perimeter of 6 to a perimeter of 12. So it'd be 2 times as long. It doesn't matter what shape you draw, this is always true. If your copy percent is 200%, everything's doubled. Your area, which we didn't talk about, would be 4 times bigger. If I put in a copy factor of 50%, that's 1/2 as times as big. So that means if I have something that's 1 by 2, then it's going to be 1/2 by 1. So your new side lengths are going to be half as big as they were. No matter what you have, a triangle or rectangle, if you're 50%, then side lengths are going to be half as times as long. Again, your angles stay the same because your shape's not changing. And your perimeter is going to be half as long again because your side lengths are half as long. If I go to 150%, that's 1.5 times bigger. My new side lengths will be 1.5 times bigger. My new perimeter will be 1.5 times as long. But again, my angles don't change because I have the same shape. If I started with a rectangle, I still have a rectangle. If I started with a triangle, I still have a triangle. 75% means it's 3/4 times as big. So my new side length is 3/4 times as long. My new perimeter is 3/4 times as long, and my angles don't change at all. 19, this was talking about circles, and we did a warm-up with circles, so hopefully did some reminders that a circle, you have a diameter is halfway across, or radius, is halfway across. The diameter is all the way across. So we're dealing with a radius right now. We have a circle with a radius of 4 centimeters. What is the circumference in the area of the circle? So just as it is, what's the circumference and the radius? And a little reminder, circumference is 2 times pi times the radius. And area is pi times the radius squared. So if my radius is 4 and my circumference is 2 pi r, then it's 2 times 4, which is the radius, and then I'm just using 3.14 for pi, which will give you 25 and 1200 centimeters. Area is pi r squared. There's my pi, 3.14. Here's my r squared, 4 times 4. So 16 times 3.14 will give you 50 and 24 centimeters squared. The reason why we're finding it before we start is so we can see what happens if we change our copy factor, if we make it bigger or if we make it smaller. So now let's do that. Let's change our copy factor to 150%. 150% is 1.5 times bigger. So if my original radius was 4 and I'm making it 1.5 times bigger, my new radius is 6, which now makes my diameter be 12 centimeters. It's just double your radius. My circumference is 2 pi r. 2 times pi times the radius, which we just said was up here, was 6. 2 times 6 times 3.14 is 37 and 68 centimeters. So our new circumference is 37 and 68 centimeters. Our area is 6 times 6 pi, that's our r squared, times pi, gives you about 113.04 centimeters squared. Suppose you copied the original circle using a size factor of 50%. What will the new radius, diameter, circumference, and area be? The new radius is going to be half as big. So if my original radius was 4, and I'm taking half of that, now my radius is 2 centimeters. My diameter is double my radius, or I could double my old one, but it becomes to be 8 times a half, gives me 4 centimeters. My circumference is 2 pi r. My radius was 2 up here, so 2 times 2 is 3.14 and 12 and 56 hundredths centimeters. And area ends up being the same this because it's pi r squared, and our r is 2, so it still ends up being 2 times 2 times 3.14 is 12 and 56 hundredths centimeters squared. So again, I know this is a little rusty, circumference, circles, radius, diameters, but I just wanted to get it out there so you could see it for a little bit. So looking at the original circumference and the original area, can you see a relationship between the scale factor and your new circumference and area? So if my original circumference was 25, and I make it 1.5 times bigger, my new circumference is 37 and 68. It's double. It's 1.5 times bigger. Same thing here with the 50%. It's half as big. So it looks like circumference is equivalent to our rules for perimeter, that it's whatever the scale factor is times bigger or smaller. And it looks like our area is the same thing that we were talking about with our area of rectangles. That's going to be the copy factor squared. So 1.5 times, or in this case, 4, so it's half, 1/4. 1/4 if it's 1/2. We'll talk more about this, about area and all that kind of stuff in class, but I just wanted to get you used to it and get it back in your mind. And the secret word, I'm throwing it at the end. I bet you thought it would have been something related to snow, but it's not. This time I'm going to actually use circle, because we've been talking so much about circles that our secret word is going to be circle. See you in class. Bye.